Jai Hind all of you once again. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering at Ajay Garg Engineering College. So, today my third complex topic from the subject of data structure is sorting, right? Although this third unit is divided into two parts, that is searching and sorting. So, I thought give a presentation on this sorting. There are number of sorting techniques which are used for arranging the elements in descending order or ascending order, increasing order or decreasing order. So, the sorting techniques which we are going to discuss today is bubble sort, right? Bubble sort, selection sort, then comes the insertion sort. After insertion, quick sort is there, then merge sort, right? Then heap sort is there. One more sorting that is called as radix sort, this is also there. So these are the sorting techniques which we have to discuss, right? So today I will give you the brief introduction of all these, but mainly focus is on these two sorting techniques, quick sort and merge sort. Okay. Although in the first year students used to study these three sorting techniques, so I will fastly just brief you what is bubble sort, right? So first of all, before proceeding towards the different sorting techniques, we should know what is sorting, how we will define. As we know that, as I have already discussed, that sorting means we are arranging the elements, right? So we are rearranging the elements, okay, and rearranging in any of the sequence like descending order or ascending order, okay, in increasing order or decreasing order. It will depend. Either the values were given alphabetically or numerically, right? So these sorting techniques can be divided into two parts, internal sorting and external sorting, okay. So it simply clarifies that internal sorting means when the list which is given that can be accommodated in a computer's memory, internal memory. So those sorting techniques are called as internal sorting. And if we have a bigger list, bigger size of a list, then we need some external storage to store. For that we use external sorting techniques. So the techniques which is in the techniques which are in our syllabus all comes under this internal sorting. All that quick sort, merge sort, bubble sort, selection sort, insertion sort, they all are internal sorting techniques, right? So insertion sort. So what this insertion sort means, I just explain you with the help of an easy example. For example, you have most of you have played cards, है ना? So those cards. So with this cards example, I just explain you how this insertion sorting works. For example, there are number of cards which are lying on the table, right? Upside down, right? One card is in my hand, right? So this is one card. This is, for example, है ना? So now I pick another card from the table. Then I will compare that card with the card which is in my hand. So I will compare. If the card which I picked is less than that card which is in my hand, I will insert it before. If it is greater value, then while after comparing the card in my hand, then I will insert afterward. So now I have two cards now in my hand. Again, I have picked another card from the table. I have seen. Then I will compare that picked card from the two cards which are in my hands. So while after seeing them, I will insert either before, afterwards, or inwards. Right now, I have three cards. Now I have picked another card. Now the card which I picked, now I will compare with that card with these three cards, and accordingly I will insert in my hand. So in the same manner, this insertion sorting works, right? So you can see the algorithm that is written here. So see, I have starting a loop with 2 to 5 because one card is already in my hand, right? One card is already in my hand. So I have started loop from 2. For example, 2 to 5. For example, we have 5 elements. Hai na? Sorry, these are the steps na? For 1 to n minus 1. So one card is already in my hand. So we will compare the card which I picked to the card. So what this comparison will take place, and we will swap the elements, right? Swap means we are going to, with the help of this temporary variable, we will swap, we will compare the element. Okay, so this is the algorithm which will be executed, right? So for example, I can just take this small example. For example, I have this 30, 20, 10, 40 and 50. These are the elements. Now I have to sort, right? So what I will done, I will compare this 30 with 2, right? So while comparing, so I will compare 30 is greater than 20, then it needs swapping. So 20 will come here, then 30 will come here. 30, 10, 40, 50. Like now I have 2 cards in my hand, right? Then we will pick 10, right? Then this 10 will be compared with these 2 elements, right? While comparing, we will see this 10 will be inserted in beginning. Then comes the 40, then comes the 50. Then this 40 will compare. 40 will compare with this 10. 10 is less than 40, no change. Compare with 20, no change. Compare with 30, no change. It means it will be inserted afterwards. 20, 30, 40, right? Then we will compare with 50. Now we have 4 cards in our hand. I have picked the 5th card, then it will compare. 10, no change. 20, no change. 30, no change. 40, no change. Then it will be inserted at last. So like this. So this is the easiest example that I have taken to illustrate, right? So this is how insertion sorting works, right? So this is the program in C for this insert sorting. So I have make a function insertion sort, right? This is the definition of this insert sort. For example, the array size is 10. Okay, I have entered the size, elements one by one. Then here I have called a insertion sorting algorithm. So when this call is take place, the control will transfer to this procedure, to this function, right? It will pass the array and n, the element, as n is the size. Sorry, this is the size. No? This is the size, and here is the element. Here, so for loop is there. Under this for loop, I have take one variable that is already in my hand. So a of I will come in temp. Okay. Then for comparing, that card will be compared with the cards in my hand, right? So for that I have initiated a while loop, right? Unless the value of this j, this counter variable, is greater than or equal to 0. The cards will exist for comparing, and a of j, the value is greater than temp. Then this comparison will take place, where I have to insert. If there are 3 elements, then the card which I have picked will be compared with 3 elements, right? Similarly, in this fashion, this loop will check. Okay. Temp, then sorting list will be printed like this. Okay. Now the selection sort. For example, in this selection sort, what we will do, the 0th position element will get compared with all the elements, right? Just see, this is an example. So we are just illustrating the selection sort. This 65 will get compared with all the elements. This will compare all the elements, right? 0th position element will get compared with all the elements. For example, 65 compared with 70. Is 65 less than 70? Yes. Not an issue. 65 will remain here. Then 65 compared with 75. Is there any issue? No issue. Then with 80, 65 is less than 80? No issue. Then 65 will compare with 50? Yes. 65 is less than 50? No. Then swapping will take place. So in here, in place of 65, 50 will come. 70, 75, 80, 65 will come here. 60, 55, 85, 45. Right? Right, students? Now next, 60 will get compared with 50. No change. And this is the 0th position element. Na? Then 50 will compare with 55. No change. No change. No change. No change. Then this is less than. Then again we will swap. So 45 will come here. 70, 75, 80, 65, 60, 55, 85 and 50 will come here. Now you see, this is the completion of our first iteration. First iteration, right? So after the completion of first iteration, you will see that the smallest element will reach at its original position. Okay? Now how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 elements are there, right? So it will take 8 iteration to sort these elements. Okay, students? After 8 iteration, elements are sorted. Elements are sorted. Okay? And what is the concept? Concept remains the same. 0th position element will get compared with remaining elements. So now next time in next iteration, this is the list. Okay, this will go for second iteration. Now we will get the second largest element. This is the smallest element. Then we will get the second largest element after second iteration, third largest, fourth largest, fifth largest, and so on. So it will take 8 iteration to complete sort the 9 elements. So this is how selection sort works. Okay, students. So you have to keep in mind 0th position element will get compared. After the completion of first iteration, we will get the smallest element at its original position and so on. Right? So this is the algorithm. And this is the program of selection sort. Right? We have used here 2 for loops. Right? Under that for loop, we have used this swapping. Okay? This is the procedure. Now comes the bubble sort. Again, it is very easy. In this case, what is bubble? Bubble means a group of element. Hai? Now this group of element will move from downwards to upward, because we know that bubble will rise from down to upward. Okay. So how the algorithm will proceed in this? For example, in this example, these 2 elements are compared. These 2 elements will compare. So 33 will compare with 44. 33 is less than 44. No change will take place. Then this 44 will get compared with 22. Yes. 33. 22 is smaller than 44. Then it will come here. Right? Then we will compare 44 and 11. Yes, again these elements will swap each other. 11 will come here, 44 will come here. Right? Now next 44 and 66 will get compared. No change will take place. Now again 66 will get compared with 55. Yes, change will take place. 33, 22, 11, 44, 55 and 66. So after completion of first iteration, you will see here we will get the largest element. After completion of first iteration, we will get the largest element at its original position. Okay. So how many elements are there? 1, 2, 3, 4, 5, 6 elements will there. So it means 5 iterations will go on. to sort this list using bubble sort. The concept is that we will compare the elements in a group and keep on proceeding, right? Now, in the same manner, so almost we have seen that in selection sort and bubble sort, the size of list is decreasing after each iteration, right? So if I will find the complexity, so I will find like this, n minus 1. Now the list is again going on decreasing, n minus 3 and so on, plus 3 plus 2 plus 1. Like, now we know that this is series sum of natural numbers, है ना? It is n square. So the complexity, worst case complexity of these bubble sort and section sort is coming out to be big O n square, right? Same, right? So this is the program of bubble sort. Here also we are using the 2 for loops. Okay, students. Okay. Now, yes, quick sort. Now this algorithm is one of the important algorithm. What makes it important? This is, we will recursively call the list, right? Here we are going to use the concept of recursion, right? List is divided into 2 parts. Again, that list will divide into further 4 parts, 6 parts and so on. It means the strategy which we are following is divide and conquer approach. We are following it, right? So these are the important concepts. So this make this quicksort algorithm important. This is also called as partition algorithm, and we are partitioning, partition sort. This is also called partition sort algorithm. This quick sort, okay, quick sort. So you can see with the help of this example, quick sort is the main function. A is the array. We have to some lower bound is there, highest bound is there. If that array exists, then we will call partition A low high mid. Again we will call partition A low mid minus 1. Again we will call partition. This is the left partition. This is the right partition, right? Exit. So what is this partition algorithm doing? Just I am explaining you with the help of example. For example, we have these elements. Okay? So for quick sort to run, we will consider one element as a pivot element. So let us consider this element as a pivot element. Okay. Let us consider this element as a pivot element. Pivot element means an element with whom we are going to compare our values. Okay. For example, this is my Q, this is my P and this is my Q. We have initialized 2 variables also, right? So what we will do, we will compare the value of these P and Q with 50, right? Firstly, we will compare, see, pivot A low, the first element will be assigned as a pivot element, right? I is equal to low, J is equal to high, right? Then we will repeat step 3 to 5 while I is less than or equal to rho. For example, I and J, I have taken P and Q. Here in place of I and J, I have initialized P and Q, not an issue. So while I is less than low, we will repeat. So just I will show you. We will see here. Now we will compare this 30 with 50. Okay. We will see is, firstly we will, for this P we will check. So in this quick sort, firstly we will consider a pivot element. For example, we have considered a first element as pivot. Okay. Now I have compared 30. Is 30 greater than 50? No. Then again, is 10 greater than 50? No. Then again, 90 greater than 50? Yes. So I will, until I am not getting the greater value, I will keep on increment the value of P. Now we will stop here. P will stop here. Okay. Now we will check Q for the smaller value. ठीक है. तो is 70 less than 50? No. Now we will decrement. Is 40 less than 50? Yes. Now the Q will decrement here and we will stop. After doing this, we will swap these two elements here. Now the list will become 50, 30, 10, 40, 80, 20, 90, 70. Okay. Now Q is here and P is here. Okay. Now again we will check. Is 40, we will check here again. Is 40 greater than 50? No. Is 80 greater than 50? Yes. So P will come here, it will stop here. Right? Then we will compare now Q. Q is on 80. Now we will compare, is 80, is this 80 is less than 50? No. Then this Q will overlap here. Q will overlap here. So now we have to consider, whenever this overlapping take place. So we have check here. Now this Q will come here. Right? Q will come here. Now we will check here while, sorry, I have leave this 20, sorry. This Q is here, na? Oh, let me rewrite this 50 after the first change 30. In place of 90, 40 will come, 80, 20. In place of 40, 90 is there, 70. Now, on this is, oh, sorry, by mistake I have written Q is here, na? Q is here, and where is P? After this, in place of 90, this 40 will come, P is here, right? P is here, right? Right, so P. So we will compare with, is 80. Now we compare 50. 80 is less than 50? No, this will overlap. Now here it is 20. So we will check here. 20 is 80 is greater than 50. Yes. So P will stop here. Right. P will stop here. Now we will check Q. Is 20 less than 50? Yes. Q will stop here. Then we will interchange these values. So after interchanging, we will get 50, 30, 10, 40, 20, 80, 90, 70. Right. Now all the elements which we have just changed here, 40, na? 40 will come here, 20 will come here. So it means P is here, P is here, and Q is here. Right? Now again we will start. Now we have seen that these two variables are interchanged, P and Q. And now the current value, firstly I have to check for the Q. So firstly I will check for the P. So whenever these variables interchange, whenever the interchange of the variables take place, we will interchange the current variable with the pivot element. So here 20 will get interchange with 50 and the list will divide into two parts. Okay. Now 20 will come here, 20, 30, 10, 40, 50 will come here, 80, 90, 70, right? And the list is divided into two parts. See. So this is our pivot element now 50. Now the list is divided into two parts. This is my first part and this is my second part. Now you can check whether the list is properly divided or not. When you compare with the pivot element, all the values less than pivot will on the left partition and all the values greater than this element 50, pivot element greater than 50 will be in right partition, right? So the same procedure will be followed. Now in this list, this is my pivot element and I will start again P and Q and again comparing. Greater value for this P, smaller value for this Q while comparing with pivot element. Again, this is my pivot element in this list 80. P P is this and Q is this. I will check greater value of P while comparing with pivot element and less value of Q while comparing with pivot element. And the list will go on dividing, and we will get individual element, and at last we will get the sorted list. Okay? So this quick sort is one of the efficient algorithm that we will use. One of the best efficient algorithm. Okay? So this is the program of quick sort here. The same procedure is followed here. The list is divided into two parts. Again, recursively it will be called. Okay. This is the algorithm that I am discussing about. Okay. Now merge sort. What is the concept of merge sort? This is the concept of merge sort. For example, the list is given. We will divide our list into two parts. Again, further divide. We keep on dividing. Then we will merge. While merging, we will sort the element. 1, 6 will compare with 4. So after sorting, we will get this sorted. Right here, 7, 9, 2 divide. Then we will merge 2, 7, 9. Sorted, and sorted. This is the concept of merge sort. Very easy. We will divide the list into two parts, 2 to 4, 4 to 6, and so on. And again, we will partition. After partitioning, we will merge. So this is also divide and conquer approaches in merge sort. So this is also important merge sort, right? So this is the algorithm. This is the algorithm here for merge sort. We will make a merge sort low and high. While comparing the array exists, we will find the mid. From mid, we will divide two parts, and again at last we will combine. So this is the combine algorithm. Combine algorithm means we are comparing the two elements of the two different lists, right? Like this. This is one list. This is second list. And after comparing, we will get the merge list. So we will compare the element with these elements are compared. For example, the element from this will come here, then we will increment the value of this A partition. Now this element will get compared with again this element. Okay? For example, now this element will come here, then we will increment this, then this element will get compared with this element, and so on. Like this, the merge sort will take place. Right? So this is the program. This is the algorithm. Okay, students. So I hopefully you will understand this easy concept of sorting. So by using any technique, you can use sorting. Okay. Thank you, students. Thank you for today.